Welcome to this video about Introduction to Integration. Integration is the process of finding the integral. The symbol for integral is the long S like that. It looks like a snake. In finding the derivatives, we have said that, for example, if your y is equal to x squared, the dy dx is equal to 2x. If your y is equal to x squared plus 1, the dy dx is also equal to 2x. And if your y is equal to x squared minus 4, the dy dx is also equal to 2x. Or in general, if you have y is equal to x squared plus any number c, your dy dx is also equal to 2x. So this process, as what we've learned, is the process from here up to there in finding the derivatives is what we call as differentiation. The process of finding the derivatives. While the integration is the total reverse of that operation. So if you're going to go from there, this is the question, and then you're looking for the curve, or if the derivative is given, and you're looking for the curve and you find the curve y, that is the process of integration, right? So in our differentiation formulas, the basic that we did was, if you have the derivatives of x to the n, if that is your y, what we did was the dy dx is equal to n x to the n minus 1. Okay? So basically, what we did is we multiply the power, or the exponent, right? And then from that, the exponent minus 1. Exponent minus 1. Right? So that process from y to the dy dx. So that process is differentiation. But since it's the other way around, this time the given is the dy dx, and we're going to that. So instead of minusing 1 or subtracting 1, we have plus 1. So the first one is the total reverse of that, plus 1 to the exponent or the power. After adding 1 to the power, instead of multiplying the power, you have there divide by the new power. Okay? And that one will give you your curve y. Let's try to have an example. So, or maybe I can just put here. So let's say I have there the integral. Okay, that is written as the integral of x to the 4th dx. So what is it equal to? We have said that this, you plus 1 to the power. So x to the 4 plus 1 divided by Okay, divide by the new power. 4 plus 1. Okay? And then that's equal to x to the fifth over 5. And then just make it equal to or plus c. Again, what's the reason why we need to add c? Because remember similar to this, okay, there are many functions with the same gradient function. The gradient is 2x. What makes them different is the plus c. You have plus 0 there, plus 1 there, minus 4 there, plus c here. So therefore, there are many, okay, there are many functions with the gradient of x to the fourth. But what makes it different is that plus c, okay? So that's it. That's how to find that one. Or in general, our formula now, we can have the basic formula, the integral of x to the n dx is equal to x, you add that power, divided by n plus 1, and then just simply add some number c. And the other formula, the integral of any constant with respect to x is equal to 0. Oh, sorry. Constant, let me symbolize my constant as, let's say a, okay, is equal to ax. Then plus c. For example, integral of 2 dx, right? The integral of 2 dx is equal to 2x plus c. How is that so? If you're gonna apply this formula here, so 2 can be written as 2 times x to the 0. And take a look that x to the 0 is 1. When you apply that formula there, so this one, we can write this as 2, okay? 2, then let's just integrate x to the 0. So 2 times the integral of x to the 0. You can put the constant outside the integral symbol with respect to x. With respect to x. So this one, using that formula, is n plus 1 over n plus 1. So this is going to be equals to 2x to the 0 plus 1 all over 0 plus 1. And that gives you 2x. Okay, that one. And then just simply add plus c. So therefore, if you have the integral of 1/3 dx, that's equal to 1/3 x plus c. If you have, for example, the integral of square root of 4 dx, that's equal to square root of 4x. If, for example, you have the integral of x plus 2 dx, okay, the integral of that is equal to, you can separate that one by one, x dx plus the integral of 2 dx, which will give you x squared over 2 plus 2x plus c. If you have, for example, the integral of square root of x plus x divided by square root of x dx. If there you have their polynomials on the top of, you have their 3 terms or many terms on the top. Remember this strategy. If you have many terms on the top and you have a single term, single below, what you can do is divide each term. So you can have the integral of the square root of x, the square root of x dx, plus the integral of x, the square root of x dx. And then you simplify it first before taking the integral. The square root of x over square root of x is integral of 1 dx, plus x square root of x is equal to the integral of x to the half dx. Then we are now ready to integrate. Integral of 1 dx is x. Integral of this is plus x 3 over 2 divided by 3 over 2 plus c. Let us just try to write this one neatly. So therefore x plus 2 over 3 x raised to 3 over 2 plus c. So this is the integral of that. I'm gonna let's stop for this. Let's stop for a while in this video. I'm gonna give you more examples in the next video.